Hey everyone, this week we have another really long video, but thankfully there should be some shortcuts in the description to get you where you want to be. I got an email through our website from someone that had seen the channel, and it was in response to the MicParts T25 video we did a few weeks back, which MicParts was kind enough to share with their user base in their monthly email they release. To paraphrase, the user said that they thought it would be way too difficult to actually build a mic and that it probably was out of the ability of most. My response to that is simply no. This channel is aimed at recording engineers and musicians that have an interest in recording mics and a bit of history. I've stated in previous video as well that learning how to use a soldering iron should be on the list of skills for anyone that really wants to be an audio engineer, for no other reason than to fix cables that often break. Taking it a step further would be building gear and things for the studio. I've gone over how much of a cost savings DIY can be in the studio for things like cables, but they can also be huge when it comes to gear as well. Like take these LA2As behind me. I followed original specs for the circuit, made some creative decisions on the transformers, which are no longer made, and I was able to put these units together for less than half of what a new reissue LA2A is currently selling for. The same goes for microphones. Last time we looked at our clone of an AKG C12. While the parts were a bit on the pricey side, the end product speaks for itself. As for purchasing an original AKG C12, good luck. They often go for upwards of 5 figures, which is a bit outside of my and probably most engineers out there's budget. Is it a classic vintage mic with some historic provenance? No, of course not. Does it sound damn good? Yeah, it does. And it still was less to put together than some of the boutique remakes that are out on the market. So where's all this going? My point here is that it's not difficult to put a mic together, and it can actually be a fun and extremely rewarding experience. With a little bit of practice and the ability to follow directions, I really don't feel it's outside the possibility for any tech-minded individual to plug in an iron and put a kit together in an evening or weekend. And that's what I'm doing in this video. I'm going to be building the MicParts S-87 mic, albeit sped up for time's sake. The total build, without my shenanigans at the end, took me about an hour and 20 minutes on my kitchen table where I didn't have any fancy equipment. So in the amount of time it would have taken me to get in my car, drive to my local music retailer, pick out a mic, check out, head back to the studio, I had a working mic that I was able to customize the way I saw fit for my intended purpose. I'd been looking for something with some good bottom end and at the same time had some decent headroom for my upright bass. Usually a FET mic is great for that, and I have a Vintage Circuit U87 in the studio that I usually use for this purpose, but I found that the bottom end on the mic isn't as full as I'd like it to be and tends to drop the bottom pretty quickly with any kind of distance from the instrument. Finding the sweet spot isn't really that easy, especially if the musician is moving the instrument at all while playing. We had a nice Mojave FET mic that was stolen from us a number of years ago and never got replaced, so this felt like a good alternative to directly replacing that, and it's way less expensive. I try not to make the build too boring, and I've never done a video like this before, so bear with me and feel free to shoot me some pointers for future videos like this. After the build, we'll check the mic out on our piano and upright bass, and you can also get a taste of what the mic sounds like on vocals as well. Let's get to it. Alright, so I'm going to take this thing from opening the box to closing the mic. So first I'm going through the box to make sure that I have all the parts that I need. Trying to organize things to keep the work area pretty clear. And I'll take a minute to look through the manual to familiarize myself with the kit. There seems to be some options available for the voicing of the mic, which I haven't quite decided which way I'm going to go with it yet, but we'll get there. MicParts really puts together a really great manual. Everything is step by step and it just walks you through the entire thing. And now I'm just going to sort all the parts by component type, so resistors, inductors, capacitors, transistors, diodes. Now, I'm going to separate the boards from each other. Now, sometimes there's some flashing on the boards that create some sharp or rough edges around the sides. And I'll just take a file and gently file down the edges to make sure those rough edges are gone. But don't file too much so that you wind up cutting into the copper layer of the board. And the first thing that I go after, I usually go from the smallest components to the largest, and the manual for the most part follows that kind of methodology. So I go from the diodes to pretty much the electrolytic capacitors at the end, since they're the biggest. Diode types, and just putting them in where they need to go. And diodes do have an orientation that you need to follow. There's a little black line on the diode that shows you where the cathode is. And the board also has the line drawn on it, so you just have to match them. I'm going to solder them in there. Now the solder that I use is very thin silver-bearing solder. It doesn't tend to leave a lot of residue on the board like a rosin core solder will. It's a lot more expensive than regular rosin core solder, but I find it to work really well. So now that the diodes are done, it's time to move on to the resistors. And the kit provided has numbers written on the resistors themselves. These particular ones don't use the color code bands, so it makes it a lot easier to populate the board. And the manual does a great job of just telling you which resistor goes where. So I try not to put too many components in before I go and do a solder run. I'll get a bunch in there, just enough so that I can get the soldering iron around and be able to make those joints as easy as possible. But I find it a lot faster than doing individual components and then soldering and then cutting and then another component, solder and cut. Just makes things a little bit faster. It's usually a good idea also to hold on to those leads when you snip them, otherwise they can go flying across the room or into an eye. Now, sometimes you get some pads that are really close together, and when you solder them, maybe you get a solder bridge between the two. So I usually check before I move on to make sure that there are no solder bridges between close pads or anything like that, and clean them up as needed. Now these two resistors are custom selected for the FET that is chosen for this particular mic, so they pretty much take care of everything that you need to do. A lot of other kits, like, you would have to wind up figuring out what the resistant value would have to be for those, and this just makes it so much easier. Now, resistors are non-polarized components, so you don't have to worry about which way that you put them in, as long as you put them in the right spot. Next we have the inductors, which look very, very similar to resistors. And you do have to be careful with these. If they overheat or crack or break at all, Even little chips can cause them to not function properly. So you do have to be careful with those. They are also non-polarized, so they can go in either way. And next we're going to move on to the smaller capacitors. There are really tiny little numbers written on them. Very difficult to see, but once again, the manual helps you out to figure out which ones go where. The manual will tell you not only the value of the capacitor, but what is actually written on the capacitor itself. And these components, again, same thing, they're non-polarized, so they can go either way. There's no orientation you have to worry about. But things are still going together pretty smoothly. No problems yet. And now we go for some of the transistors here, and it's very important to put the transistors in the right way. There's a little diagram on the board itself to show you the orientation of the transistor. Usually there's a round side and a flat side, and obviously the flat side goes to the flat side and the round side goes to the round side. But it's very important to make sure that you do put them in the proper way, otherwise the mic won't work. And at first I actually did screw up putting these in, and I did put them in the wrong way, but I did catch it before I finished the mic up and fixed that up. Next are the film capacitors. These are all made by WEMA, which is a really, really good brand of capacitor. They don't tend to be cheap. And we do have a choice here as to how to voice the mic by selecting a certain value of one of these capacitors. The one that I'm putting in right now is to make the mic as flat response as possible and not rolling off a bunch of the high end. Matt does mention in the manual that he suggests using one of the roll-off capacitors for the K87 capsule. But I want to try it flat first and see if I like it. If I don't, I can always go back and take that one out and pop a new one in. Next we have the little toggle switch here, and for this mic it has a dual purpose. You can set it to either change the polar pattern of the mic from cardioid to omni, or you can make it into a pad. Since almost all of my pre's have pads on them, I think having the polar pattern selection would be way more useful, so that's the route I'm going with this. Next we're going to pop in the electrolytics, which are usually the biggest components, and these are polarized. You do have to make sure you put them in the correct way. And we also have a trim resistor, which is like a little tiny pot. This will allow us to tune the mic to make sure that the voltages are proper and the mic is performing at its best. If you notice, we got a bunch of capacitors that are still sitting there. They give you the alternate capacitors for the different voicings, so it's up to you to pick which one that you want, which I think is pretty cool. So you don't have to go out and, you know, purchase a different capacitor if you want a different voicing. He gives everything to you right there. And there's one resistor left also that is going to connect to that little toggle switch that we put in there. And there's a little weird way you have to do this. There's a four-way connection here between the toggle switch, the FET, the capsule, and this resistor. And you do have to be pretty careful there. You don't want to break off the lead. It's pretty delicate. You also want to make sure that nothing is going to wind up touching the board on that junction as well. So popping that in there properly is pretty important, and making sure you got a really clean solder joint there and nothing is kind of hanging over or hanging down or bent. And now, as per the manual, I'm just going to clean up the board with some 99% isopropyl just to get any residue off the board. Again, the solder I use doesn't leave a heck of a lot of residue to begin with, so this is pretty easy. If you use a rosin core solder, you might be sitting there for a few minutes trying to get that gunk off. And next up is the capsule mount. I'm going to take off the stock mount and pop in their super saddle. To me, it looked like there was a orientation for this, but it turns out it was just a optical illusion, and they were the same on both sides. But either way, went in pretty easily. And next up, we're going to get the capsule prepped and ready for it to be mounted. There's a few things that we have to do here. We have to electrically connect the two back plates from the two sides of the capsule. And to do that, we're going to take one of the little leads that we clipped off from one of the diodes or resistors before and make a little loop, and that will wind up being enough to make that connection between the back and the front. And just check to make sure everything fits. And again, you got to be very, very careful when handling the capsule. You don't want to touch the membrane at all. It's good to always familiarize yourself with it. Make sure you know where all the screw holes are so it goes in easy and you're not having to screw things and unscrew things. Now I'm just going to check to make sure that the capsule is going to seat well into the saddle. And once I get the orientation correct, I just pop one of the screws in kind of loose, make sure it's fitting well, and then pop the other one in and then tighten them up. If you tighten one side first, sometimes you can kind of bend the saddle out a little bit and just hard to line up the second screw. Then we feed the leads through the front, and now we have to deal with the back plate. There's a lead that he gives us with the eyelet that we can screw in with these very tiny screws, and now we take that little loop that we created before and pop that into the rear plate and make sure that the lead connects from the back to the front. Once that's done, trim off the little remaining piece there. And now I want to make sure that the back and the front back plates are electrically connected, and they are. Now I'm going to put the head basket on temporarily just to make sure things don't wind up on the diaphragm itself. So just keep that clean and nice. And then next we're going to run the jumper wires from board A to board B. It's just a little piece of wire. going to take out the screws here that were given to mount the board onto the chassis. And then we have to connect the backplate wire to the board. And it's all the way at the top there, so it's... And the backplate wire needs to get trimmed back pretty far since it's a long wire and it doesn't have to go very far. So we trim it down to a decent length that if you need to remove it, you can, but you don't want to make it too short either. And I put this bag over the grill here just because we're going to have to do a couple more solder joints, and I don't want to take the risk that a little bead of solder or something may pop off or get flung off somehow and wound up landing on the capsule, so just cover that to make sure. And the chances of that happening are pretty slim, but this pretty much makes it 0. And we're just connecting the front to the back now and connecting the XLR wires to the bottom of the board here. You don't have to use a ton of solder, just make sure that the connection is made and the pad is covered completely and connection is solid. I'm gonna trim off the leads from the capsule. We have the front and the back lead. Now the back lead has to go to one pin of the little toggle switch that we had before, and the front gets connected to the junction that we made before between the little toggle switch, the resistor, and the FET. And we just trim that down. And we tin the wires. And the reason that we do that is because we don't want to be sitting there trying to cook that wire onto the junction. Since we have 3 things that are going to be meeting there, we want to use as little heat as possible and get that connection made as fast as we can so that nothing really pops out or comes loose. And I put a little piece of shrink tubing over the rear diaphragm lead. Just make sure that there's nothing that can kind of touch it or get in the way there. And now to connect that front diaphragm there, bam, that's it. Just a quick little touch of the iron, make sure that it's connected solid and that it's clean. Make sure that there's no debris or anything on there and it's not touching the board or any other component. And now I'm gonna secure the head basket and pop this back together, and I think I forgot to check to see that the toggle switch was set to cardioid. I did that, and that's it. Mic is pretty much complete. Now on to the calibration. And all we have to do here is make sure that the test point by one of the diodes here is set to a certain value. In this case, I'm trying to get this voltage here set to 60 volts. And to fix that, all we have to do is turn the little trim pot that we have there with a flathead screwdriver. Mine was at 62 volts, so I just got to turn that down and hit 60. And we're done. And last but not least, I bring this into the shop area with our CNC laser and I pop my logo and a serial number on it. And this mic is ready to be tested. Yeah, that was long. Okay. So about the vocal test. The entire voiceover for the build video was done with the stock S-87 before I changed out the high-end filter cap. I felt the mic was a little bright, not as bright as what it was made out to be in the manual, but swapping out that cap and the mic rolled off just enough top end to where I'm really happy where the mic is right now. Do you think you might try to build something in the near future? Maybe some cables, a direct box, anything? If you want any advice on an easy kit to start with, or what kind of soldering iron to use, or solder, hit me up in the comments. I just set up an Instagram account, and the studio has a website and a contact form, and we also have a Facebook page that I've neglected for the past dozen years or so, because Facebook. But I'll start looking at it again because some viewers here have found me on there and have sent me friend requests and messages and suggestions for future episodes. And yeah, I will take requests within reason. Tell me what you thought of the video. Was it too long? Was it too short? Said no one. And FYI, the angle for the filming of the build was intentional since I didn't want the video to be so clear and direct that someone could potentially copy the design. That wouldn't really be fair to MicParts. If you're interested in building one of these or any other great kits that they have to offer, check them out. There's a link in the description. As always, if you got anything from today's video, please hit the like and subscribe button so we can continue to bring you videos every week or so. That's it for this time. This is Pags, signing off.